Hello and good day. Welcome back to our class. This is teacher Oded Guzman, and our topic for today is solving quadratic equations by extracting square roots. Let's recall the square roots of the following numbers. Say for instance, if I have the square root of 16, so this will give us square root of 16 is equal to positive or negative 8. Next, if I have negative 25, since I have negative outside, so I'll simply write it, then the square root of 25 is equal to 5. Next one, the square root of 64 is equal to plus or minus 8. Next one, so we have the square root of 279. This will give us 17. So we can rewrite plus or minus 17. Next, if I have the square root of 81, so this will give us plus or minus 9. Next, the square root of 121 will give us plus or minus 11. Next one, the square root of 36 will give us 6, but take note it is a positive or negative. Moving on, if I have square root of 0.16 or 1600s, I can rewrite this one as the square root of 1600s is actually 16 over 100, or I can extract the square root of 16 that is equal to 4, while the square root of 100 is equal to 10. And take the lowest terms, so divide both the numerator and denominator by 2, so I have 2 over 5. To number 9, so again, so we will take the square root of 16, so this is equal to 4, while the square root of 25 is equal to 5. So that is why this is the answer for the square root of 16 over 25. And finally, if I have the square root of 64, like what we have done in number 8, I can rewrite this one as 64 hundredths or 64 over 100. And take note the square root of 64 is equal to 8. All over the square root of 100 is equal to 10. But the numerator and denominator is divisible by 2. So I have here 8 divided by 2 will give us 4. And 10 divided by 2 is equal to 5. An alternate method of solving a quadratic equation is using the principle of taking the square root of each side of an equation. So if x is equal to a, if I'll extract both sides of the equation, so if I'll write here x squared is equal to a, take side or take the root of both sides of the equation, so I'll come up with x is equal to positive or negative square root of a. So let's have example number 1. Solve the equation t squared is equal to 64. So again, so I'll extract both sides of the equation. So I have square root of t squared is equal to plus or minus the square root of 64. So therefore, so t is equal to plus or minus square root of 64. But the square root of 64 is equal to 8. So therefore, so t is equal to plus or minus 8, or we can say that t is equal to 8 or t is equal to negative 8. Let's have example number 2. Find the solutions of the equation x squared minus 16 is equal to 0 by extracting square roots. So first, isolate the squared factor. It means that I'll move here, or I add both sides of the equation by 16. So if I add both sides of the equation by 16, so I'll come up with x squared is equal to 16. So if I have here x squared minus 16 is equal to 0, add both sides of the equation by 16. So I come up with x squared is equal to 16. The next thing that we will do is, okay, take the square root of both sides of the equation. So that is square root of x squared is equal to positive or negative square root of 16. So x is equal to positive or negative 16. So x is equal to positive or negative 4. So we can say that x is equal to 4 or x is equal to negative 4. Let's move on to example number 3. Find the solutions of the equation x minus 4 squared minus 25 is equal to 0. So again, so what we're going to do is isolate the squared factor. So that is, we will add both sides of the equation by 25. So if I add both sides of the equation by 25, so I'll come up with x minus 4 squared is equal to 25. So now that we know that this is the, okay, isolated factor, so we have x minus 4 squared is equal to 25. Then the next thing is subtract the square root of both sides of the equation. So that is square root of x minus 4 squared is equal to plus or minus 25. So I have here x minus 4 is equal to plus or minus 25. So we can say that x minus 4 is equal to plus or minus 5. But I'll add both sides of the equation by 4. So I can have now x is equal to 4 plus or minus 5. Now, I have two values here. So I'll consider that x is equal to 4 plus 5, which is equal to 9. So that is the first case. On the other hand, I have here x minus 5 is equal to negative 1. So therefore, I can say that x is equal to 9 or x is equal to negative 1. Let's move on to problem number 4. Solve by taking square roots of 3x squared minus 36 is equal to 0. So the first thing that we will do is we will isolate the variable x squared. So meaning to say, if I have 3x squared minus 36 is equal to 0, so what we're going to do is we will, okay, add both sides of the equation by 36. Okay, so if I add here plus 36, plus 36, it means that I can factor out already the negative 36 plus 36 is equal to 0. So it will result to the equation 3x squared is equal to 36. The next, divide both sides of the equation by 3. So I come up with x squared is equal to 12 because 36 divided by 3 will give me 12. Okay, the next one is take the square root of both sides of the equation. So that is square root of x squared is equal to 12. So I have now x is equal to plus or minus square root of 12. But take note that 12 is not a perfect square number. So I'll factor plus the 12. So I have, okay, the factors of 12 that has a perfect square number is 4 times 3. So take note that the square root of 4 is equal to 2, leaving only 3 inside the radical symbol. So I have here x is equal to plus or minus 2 square root of 3. Let's move on to problem number 5. Solve by taking square roots. So we have 4 times z minus 3 squared is equal to 100. So the first thing that we will do is isolate the squared factor. So that is why we have 4 times z minus 3 squared is equal to 100. So if you will divide both sides of the equation by 4, so we'll come up with z minus 3 squared is equal to 25. So let me show you that one. Again, if we will divide both sides of the equation by 4, so you can isolate now here that z minus 3 squared is equal to 100 divided by 4 is equal to 25. Next, take the square root of both sides. So I have here the square root of z minus 3 squared is equal to plus or minus square root of 25. So I have now z minus 3 is equal to plus or minus 25 or square root of 25. So I have here z minus 3 is equal to plus or minus 5. So I have two values now. But before that, I'll add both sides of the equation by 3 to isolate the variable z. So I come up with z is equal to 3 plus or minus 5. Okay, so to consider now the first value of z, so that is z is equal to 3 plus 5 is equal to 8. The other value of z, that is 3 minus 5, so that is equal to negative 2. So therefore, z is equal to 8 or z is equal to negative 2. Let's move on to problem number 6. Solve by taking square roots of 5 times x plus 5 squared minus 75 is equal to 0. So the first thing that we will do again is isolate the squared factor. So it means that if I have here 5 times x plus 5 squared is equal to 75. So the next thing is, since there's a 5 outside or a common factor of both sides of the equations, so factor it out. Meaning to say, divide both sides of the equation by 5. So I can factor now 5. So it will result now to x plus 5 squared. But notice that 75 divided by 5 is equal to 15. Next, take the square root of both sides of the equation. So we have square root of x plus 5 squared is equal to plus or minus the square root of 15. So I can remove the square root symbol and squared. So I can have now x plus 5 is equal to plus or minus square root of 15. Now, I would like to isolate the variable x. It means that I'll subtract both sides of the equation by 5. So I come up now with x is equal to negative 5 plus or minus square root of 15. Take note that square root or 15 is not a perfect square number. So we will leave this one as it is because there's no other factors of 15 that has a perfect square number. So therefore, we can say that x is equal to negative 5 plus square root of 15 or x is equal to negative 5 plus or minus square root of 15. So that ends our discussion on solving equations or solving quadratic equations by taking the square roots. So again, this is teacher Onan de Guzman. Do not forget to subscribe to my channel so that you will be notified about my new videos. Thank you.